It's about the intersection of tradition and innovation when it comes to neuroscience, the brain science. How about that? What do you think about it? Somewhere around 2,500 years ago, the Buddhist monks used to be sitting and doing mindful meditation, claiming that it's actually transforming their minds. But today, us neuroscientists in academia, in top-notch academic centers, we sit, we think, and we formulate ways to understand the brain dynamics. We attach sensors to the brain surface. We use other methods to look into the brain, and it turns out to be true. I mean, the Buddhist monks were true. They were right. Actually, today's science elaborates on the fact that when we do meditation, actually the connections in the very front of the brain are getting reinforced, and we have some structural and functional changes in the brain, which actually happens. And not only that, but it also reinforces the memory function, and it helps us to formulate new thoughts and configure way of cognitive consolidation, thoughts, and memories, and attention, learning stuff. Also, motor and sensory function. There is an interface between what we are referring to as the ancient tradition, as opposed to scientific innovations, and current and future innovations. The scientific discoveries have been shedding light to what the ancient wisdom is all right about. And some sort of like ancient approaches that we used to be referring to them as pseudoscience today turn out to be validated by the scientific discoveries. But they are not two different things. Actually, they are not at odds. They are two different sides of the same coin. I mean, we're using the modern today technology to scrutinize what is right about the brain. And we're nothing but our brain. So the more we know about who we are and how we perform, the better we can move forward with the way that we can modulate the way we think, the way we feel, the way we put together ideas, how we navigate the world, and our sensory motor functions. This is one of the examples how we read the brain. We're actually putting stuffs like this. They're actually composed of a number of electrodes, and we're actually looking into the dynamics of the neural functions. Under each and every of those tiny little electrodes are millions of neurons. And we'll listen carefully to how the neurons function and how they are generating these waves and stuff, and putting into computational modeling, seeing what happens in the brain. This is another way. It's not only about the electricity, but also the way that we are studying about the oxygen delivery to the brain and other physiological dynamics. So it's a long story, but it's actually happening today. And in the programs of neuroscience, students will learn how to study the brain, how to read the brain. And only after that, they'll be able to configure ways how they can write in the brain and change the brain for better. So what ancient science tells us, or ancient traditions tells us, is actually partly found to be very true and actually leaving some tangible changes in different dynamics of the brain. We know that the both sides of the brain, in the temples, we got the area called hippocampus. And the traditional Chinese medicine, or something we call it acupuncture, once referred to pseudoscience, today it's found to be very essentially beneficial in modulating the networks responsible for pain processing in the brain, right? So there are ways that we can utilize the wisdom of the past with the modernity of the current era to look into our brain, to read the brain, being able to write the brain, to change the brain for better. And other advanced technologies are coming to the scene, like virtual reality and FNIRS, which is looking into the oxygen dynamics, or oxygen delivery to the cortical areas of the brain, and many other modern technologies of the same realm. This is what we call brain mapping. So we're looking into the brain wave dynamics and the way that those different types of brain waves are getting distributed in various areas of the surface of the brain, what we call it cortex. So we'll look into the power of each and every frequency, and that tells us about the functional dynamics of how my brain and your brain functions. And here's the thing. Brains are fingerprints, and our brains are quite different. And we have something called functional structure, structure of the brain and functional map of the brain. And we are quite much unique. Brains are very peculiar, and they are completely differentiable in terms of all those bits and pieces of functional parameters. Chinese medicine, acupuncture, many other things, herbal medicine, what we call it generally as TCAM, or traditional complementary alternative medicine. They are actually the basis of what is founded upon the ancient traditions, but today we have clear pathways to investigate and to verify to what level they are true and not true. But something is for certain in many instances. What is good is right. And what is right is probably good. So when we're able to navigate those things and being capable of showing this thing in real life, then that's the point that we say, okay, we're good to go. This is what happens after acupuncture comes into real clinical practice. And there are many centers in the world that they are dealing with this approach or other approaches that back in a time we didn't have quite enough evidence to defend about the validity and reliability of those approaches. I'm not saying these are the best approaches or the worst approaches. As long as we're talking about evidence-based approach, we're talking sense, right? So it all depends on evidence-based and what science tells us about that. And science is about investigation, observation, being tangible, right? And those are actually the changes which actually happens in the brain after quite a number of sessions of acupuncture. So they modulate the pain perception networks in the brain. They're mostly in the back of the brain and sides of the brain. When we're already done with reading the brain, we know what's there, then there are ways that we can write in the brain and we can change the brain for better functional dynamics. And that all roots in what we call it neural plasticity. Our brains are miraculous, and it has the ongoing capacity of reshaping itself, remodeling itself. But sometimes we know that, all right, meditation is good, but how about neural feedback? Neurofeedback is like doing meditation on steroids, right? So this is like a passive way that we're steering the role, and we're helping the brain to reach those goals even faster and more efficiently. So there are actually the ways of potentiating or reinforcing how we can modulate or reform or remodel their brain for better functionality and quality of life. We've got different ways of modulating the brain. These are called neuromodulation, if you're interested in that. One of them is neural feedback / biofeedback, which is like an active way of getting brain-computer interface where the person is able to modulate how the brain puts together functional specifics. This is biofeedback and neural feedback. We also have TMS, stands for transcranial magnetic stimulation. So you just kind of change the magnetic electrical field of those millions of neurons where you put the electrode. And it turns out to be completely evidence-based approach, being validated by scientific authorities and being an auxiliary and like an additional tool for the purpose of brain training and helping the brain thrive. We got tiny little electrical current is going to pass through certain areas of the brain, and they're also able to change the brain. This is exactly where we write in the brain. We change the brain for better. Is that only for the diseased people, or those people who are challenged with an insufficiency or predicament? Not necessarily. Even healthy individuals can use those neurotechnologies to level max their performance. And that's what real science is now talking about. I'm pointing out to neuroscience, if you will. But most of us have heard about BCI, This has been helping today in real life. It's now being able to help people who are completely paralyzed to communicate with the surroundings. So they are able to connect with the environment. They are able to read, to talk, to navigate the world, and to stay connected. And that refers to brain-computer interface. We have the brain-brain interface. We have the brain-machine interface. Imagine that you are on the wheelchair, and just with the command of your brain waves, the wheelchair will be able to follow your brain commands and moves forwards, right, left, stops, right? So that is how the brain can control the machines. And now we're talking about those technologies at the age of AI. Let's face it. Now we see that there is a complete battle between different platforms of AI, and AI is like booming these days. Artificial intelligence, machine learning, reinforced learning, robotics, many things. Yeah, that is true, and in reality is happening. And we're even talking about something novel, like brain implant or those neural microarray chips that they're going to modulate the brain, how the person can feel, can think, can function in a sensory or motor way. And this is claimed to be able, in kind of near future, to transform the lives of the people with disability, which is quite exciting, right? Would you say it's exciting? Yeah? Is it? And is it safe? Okay, it might be safe, and it might be very exciting. Brilliant. But here's my point. How far is far? How enough is enough? If we're talking about the ever-growing advanced technologies in today's life, we physicians, we scientists, we entrepreneurs, we technology experts, where we're going to draw that ethics line? What's going to happen to us as human? Is it going to be for the betterment of our function as human beings? Or someday it's going to be used against us? Think about confidentiality, your sleep, your dreams, your personal thoughts. If I can scan your thoughts and I can read it on my gadget, what will happen? Would that be any privacy? Right? So there are many red lines that we definitely got to be thinking about it, and we need to take measures to regulate the ever-growing technology. But in reality, it's happening. Right? So let's put it together, and let's be also focused on the implications of ethics, honesty, and integrity in what we're taking to the table. And I'm leaving you with this. Imagine you are about to preserve one ancient tradition, and you're about to choose one neurotechnology to zap your brain and have a better brain, even better brain. Which one you choose from the ancient traditions, and which one you choose from the modern neural technology? I'll leave you with that. Think about it. Thank you so ever much.